Before I get into it, I'd like to say a massive thank you to Rotary SMP for giving me a shout out on his channel, which has given me a big boost in both views and subscribers. The plan here is to cut a relatively straight line so I can widen the cylinder by 14.5mm. The cut ended up a little bit wonky on one side, possibly due to the fact I didn't take my time. And a piece of sandpaper and glass were all that was needed to save the day. I didn't film much of the welding as this was done at work. Now, if you know about welding cast aluminium, you'll know how much of a pain it can be, especially when the castings are cheap. The work involved TIG welding in a strip of 3mm aluminium that I had cut in the guillotine. I preheated the casting and used 40-43 filler rod. Once the welding was done, I left the cylinder to cool down slowly in an oven to avoid cracking. The cylinder head was the biggest pain to weld as it wasn't new material. It had been oil contaminated in the past, and despite cleaning and wire brushing the part, I had one section that proved to be a complete pain. It came right in the end though, when the filler material outweighed the original casting. The next thing to do was figure out how I was going to face the mating surfaces. First up was the cylinder head. I decided to remove the bare minimum amount of material so I didn't significantly increase the compression ratio. This was done by resting the head on a 1-2-3 block and gripping it in the vise. I used my 50mm face mill at around 1500 RPM and a feed rate that looked pretty good. For the cylinder, the lathe was the logical choice. I gripped the outside of the iron liner and took 0.1mm from the upper face. Now, the next operation had me scratching my head for a moment as my 3-jaw chuck wouldn't fit inside the cylinder to machine the lower face. So I contemplated doing this in the mill and coming up with a program to avoid the liner, but doing it in the mill reeked of effort. And this is when my inner laziness came into play, or as I like to think of it, efficiency. I was looking at the chassis jig and I had an epiphany. I would use the 2 nylon cones on a threaded rod to hold the cylinder hard up against the chuck. And here you can see, up close, the awesome finish left by the lathe on top of the cylinder. I also got a close-up of the cylinder head so you can see the difference in surface finish between the milling and turning. So here you have the widened cylinder and head. The only thing I haven't quite figured out is exactly how I'm going to do the head gasket, but I will come up with something. Now we're off to the new drill press to drill some holes. First up, I need to mark out the location for the sump plug with my trusty Starrett combination square. And that looks pretty good. So now I just have to set the case up level. So there is a straight line between this hole and this raised area here for the oil gallery. I'm just going to eyeball it with a square. Give that a pinch up nice and tight. Now, while it's still drilling central, swap this drill bit out for the 7mm. I tested this by placing it through the oil pickup hole on the original case, and it was the largest drill bit that would slide into the hole. And here's a hot tip for young players. If you can, always start a tap in the lathe or drill press. It will ensure a perfectly straight thread every time. And once you've established the first few threads, you can then finish off tapping the hole by hand with a tap wrench. So now we've gone and finished with this hole here. This face will probably I'll need to do a better job of this. That won't be too hard though. Probably do that with a file, to be honest. Won't take too long. Just clean off these lips. So that's sweet. The hole goes, I probably can't show you on camera too easy. Straight through into here. And that should be big enough to provide a sufficient amount of oil. I could always drill it out another ½ mil if need be, but I think it'll be okay. So next, I have to drill a hole here. I've already spot drilled this. This was spot drilled on the mill when I spot drilled these holes. So that one there will come through here and into here. So this is where the oil from here goes through the pump, gets dumped out here at pressure. It feeds into here. This leads to the clutch cover and then into the center of the crankshaft and to the big end pin. And then here, I'll draw this out and I'll have to make a small reducer to maintain the pressure. I'm just going to copy the factory one, and this provides oil to this stud, which carries it up to the head. So on the factory engine, this is the small fitting I'm talking about, so I'll just measure the size of this hole here, and I will make a press-in piece, or this even looks like a grub screw, to be honest, that's had the center drilled out. I could just do that, and then that way I can put this in, take it out, if it needs to be changed at any date. So I'll set this up with this face here perpendicular to the drill. So I'll use my 1, 2, 3 blocks to do that on the angle clamp, and that should be pretty quick. So excuse the poor lighting, it's just this corner of my garage. But so what I've done is there's a small gap down there underneath the part. So what I did was, on the edge of the angle plate, I needed the spacer and my 1, 2, 3 block, and I just lifted the part up. So this face was hard up against where the cylinder bolts to, and then I pinched the case up down the bottom, and yeah, now everything's perpendicular. I'll slide the angle clamp round to locate the drill here, then I'll center drill, and then I'll drill a 5mm hole so I can run a 6mm grub screw. Now all I have to do is chuck the 6x1 tap through the hole. And of all the ways I could have opened up the oil passages, I decided the best way was to just be a cowboy and slam it with the cordless drill. and the end result was nothing short of perfect.